These sounds are a handful of results from several months of on and off research and testing to try and replicate the authentic sounds of steam locomotive whistles through the power of 3D printing. Most of those were the more successful tests from this research. I'll be taking you through the rigorous process that it took to finally find the voice of these whistles, starting from the beginning around May of 2025. Just starting out, I didn't think it was possible to make a good sounding whistle out of 3D printed parts. Materials made from plastic as opposed to brass and bronze didn't seem like a feasible approach on the surface. I had seen others create rudimentary PVC whistles in the past, so it began with using 3D printed parts fitted into PVC pipes to create single tones. This was mainly to feel out what was possible with 3D printed parts, so here's some examples of me messing around with that with shop air and an air nozzle. There's my first lesson in overblowing a whistle, but anyway, the tone sounded strange and was easily identifiable as PVC, nowhere near close to a real whistle, so I began looking into printing the whistles from scratch. I tried my hand at designing a custom whistle after a little research of the different styles of steam whistle shapes and came up with this 4-chime design. It was a 2.5-inch whistle with little pitch variations, something that could fit on the print bed and glued together with the top and bottom half. I hadn't designed it with any pipe fittings yet. I was only using an air nozzle pointed up into the inlet from below. So here's what that sounds like. The different tones registered, but they sound dissonant and almost sound more like a European horn. Looking back at it now, I see the distance between the aperture and the bell lip was probably too small and the pitch variation wasn't broad enough. I scrapped the design and tried more pitch variation and increased the bell diameter, bumping it to a 3-inch 6-chime. Additionally, in the interest of saving filament from support material, I designed it to be printed inverted with this helix, which gave it a cool, quirky look kind of compared to the traditional step whistles that you'd normally see. Here's what those sound like. This design yielded a broader tone, and at this point I thought I had it figured out, and that's all there was to 3D printed whistles. I thought there wouldn't be a way to get anywhere closer to the real ones. Another month goes by with this whistle, and I wanted to look again to the drawing board. I thought of going bigger with the next design and trying a different chime variant, this time a 4-inch 5-chime. Almost sounds like a step back from the previous version. I enjoyed the broad spectrum of notes on the 6-chime, so I tried that one again with this bigger diameter, since I knew that would make it louder. This one was the first design to start using pipe threads for the inlet. Before I started using the air fittings, I tried the shop air nozzle first. And then here's the test directly connected to the 120 psi source through a 1/4-inch national pipe thread fitting. I could tell with the direct connection that not all the notes were resonating correctly, so improvements had to be made. Up until this next design, I had been designing my whistle bowls with this direct flow of compressed air. The air would travel into the inlet and then be channeled into this converging path straight to the aperture, or the steam emission slit. I unknowingly sabotaged myself from the beginning with this design. Real whistles don't typically have this type of air inlet shape, so after identifying that, I attempted using a traditional bowl design that would allow the air to churn and expand first in the bowl before being pushed through the aperture. I drew up a 3-inch 6-chime with the newly implemented bowl. Being smaller in height, it had a higher pitch. This design felt more balanced than the rest, despite its cute little size. The novelty of the little whistle was satisfying in the moment, but with time grew more interest to keep digging. For some reason till now, I had been making custom designs with no thought to the note pitches. I had been blindly stepping the notes equally in the hopes it would make a chord. I looked up real drawings of whistles that railroads used, and I was far too ambitious and chose the Hancock long bell 3-chime, the big boy whistle. This thing was giant compared to the rest of my designs, casting them in its menacing silhouette, just as its real authoritative sound was meant for. Its full 6-inch diameter called for slicing up into multiple parts and a couple rolls of filament just to prototype. I thought I ought to keep to the direct connection design, but for some reason still made my own bowl for it. I think the difference in flow dynamics between steam and compressed air was clouding my judgment, but that's what these experiments are for. Well, as it turns out, when stepping up the whistle size by another order of magnitude, it becomes very thirsty for airflow. So I had to bump it up to a 1/2-inch National Pipe thread fitting to provide that, still at 120 psi of shop air. I was satisfied at the time with this result, yet unsure if all 3 notes were resonating properly. Things seemed alright with this ball valve setup, and I was content for a little while, wanting to try different real-world whistles. I chose a smaller whistle after making one of the biggest ones out there, and landed on the Northern Pacific 5-chime. Again, I followed the real drawings, but this time incorporating the actual bowl design too. This meant the aperture was inset slightly from the bell lip. I would have included a recording of this test, although I had deleted it after it was a fail, as the whistle was just screeching with this design. This was including a redesign of the lip, since the real whistle accounts for the thickness that the brass would need to be. With these plastic 3D printed ones, the lip can come to a fine point since it's not undergoing high temperature steam pressure, which seems to make airflow smoother over these whistles. I felt defeated by these results with several filament reels spent and no further jump in progress. A couple of months go by and my interest was relit. I wanted to keep to the authentic designs without having to go through so much filament, so I devised a plan to retain the note pitches but reduce the diameter to 4 inches. This would allow the whistle to sound like the original but just not as loud. Being smaller, the whistle won't require as much airflow. After looking up real whistles again, I found myself drawn to the sound of the Santa Fe 6-chime. It sounded like a well-balanced whistle with a broad tone. Being a tall whistle for a printer, it was designed in pieces again, and for some reason again, I was just convinced that the first bowl design I started was the way to go. This one was designed with modularity in mind and adjustability to fine-tune the whistle, so the languid plate was given a larger hole in the center to change the opening size of the aperture as needed. The bell was designed with separate spacers to adjust the bowl to bell lip height, as I had found that the whistle is sensitive to this adjustment. Here's that first test of the Santa Fe 6-chime. It sounded okay to me, but still sounding like a lot of air was bypassing and not resonating properly. After adjusting the height with the spacers and moving the aperture around with better results, I looked to the design of the bowl, since this was the easiest thing to improve. Stubborn and looking at the real bowl design, I questioned myself how the airflow striking a flat face of the bowl before expanding into the chamber was going to help the whistle's airflow. Still, I tried it, designing up a close interpretation of this 4-inch design and trying it the next day in the shop, and what I heard caught me by surprise. I was astonished by how different the whistle sounded with this redesign of the bowl. It sounded completely different with every note resonating like a true whistle. With this followed several more tests with different air sources around the shop and different attacks on the flow control. This had been the most well-balanced sounding whistle I had printed, and this felt like where the 3D printing would be able to peak at for steam whistle replicas. This brings us to the last of the designs. I went back to the design of the Northern Pacific 5 chime and drew up a new model for it, this time designing with what I knew worked. I kept the bowl shape and diameter and effectively only changed the pitches of the notes. The interesting thing about the Northern Pacific 5 chime is the cross-section that shows how each note has a different area depending on the pitch. The lower notes have a larger area than the higher ones to account for the higher pitches carrying sound farther. Here are those tests now. At this time, I think I've gotten to the end of my research, and I'm more than happy with the results. I'll play a handful of more tests that were performed after bumping up the inlet to a full 1-inch National Pipe Thread ball valve before ending the video. If you're interested in printing a couple of these whistles out yourself, I have published the designs for my replicas of the Santa Fe 6 chime and Northern Pacific 5 chime on thingiverse.com. These designs have only been tested to 120 psi, so please take the necessary safety precautions and wear hand, eye, and ear protection. I'd say some key takeaways from this project would be for me to research my direct references more closely and iterate off of those up front. I had some assumptions going into this, and the testing was an interesting challenge for me over the year. In the future, I might look to designing a 5-inch whistle which should give it more body in its tone, most likely a 6 chime since those resonate well with me. I might also look to more modern train horns, though I'm unsure of what projects I'll tackle in the later future. Currently, I've been slowly chipping away at a 1/32 scale Pennsylvania Railroad A5 switcher, meant for G-gauge track as an unpowered model. Thank you for your time and sticking around to the end of the video, and let me know of your experiences and knowledge of steam whistles and your thoughts on this project.